Good morning, everyone. Today we are going to go through problems and solve the problems of chapter 2. So we are done with the chapter 2. We have seen all the definitions and we derived the equations. So now it's time to go to the problem solving phase. So just to mention that these problems that we are going to solve, they are on pages 49 up to 57 in the book that you have on the files directory. So let's start by the first problem. The way we are going to do is that we are going to read the given, discuss it, and then to solve the problem just next to it. And that's the reason why I choose this app. So let's read the the given. A particle moves according to the equation x equals 10t squared, where x is in meters and t is in seconds. You have to find part A, the average velocity for the time interval from 2 seconds to 3 seconds. And in part B, we have to find the average velocity for the time interval from 2 to 2.1 seconds. Okay, let's actually start with it. So what we have to determine in both parts is the average velocity. Of course, you all now know what is the average velocity. You remember the average velocity as we have defined it, it is delta x divided by delta t, where delta x, it is x final minus x initial divided by t final minus t initial. And not to forget that x final, this is nothing else than the position x evaluated at time t final, and x initial, when we say x initial, that is equivalent to say it's the position x evaluated at time t initial. So don't forget these two important notions. And so now let's go on with the solving. So in part A, we can say that v average, it is equal to, so x final, it is, we have in the first part, they're asking for the average velocity for the time interval from 2 to 3 seconds. That means that t final is equal to 3 seconds and t initial is equal to 2 seconds. So that results in, so x evaluated at time t 3 seconds minus x evaluated at time t 2 seconds divided by 3 minus 2. So we end up with 10. X at time t equals 3 seconds. It can be deduced from this equation. So they told us that x as a function of time is given by this equation. So 10 multiplied by t, in this case it's a 3 squared, minus 10 multiplied by 2 squared divided by 1. And so the answer is 50 meter per seconds. So that's the result in the part number, the first part, number A. Now in part B, the question is the same. We have to find the average velocity, but for a different time interval. And in this case, t initial is equal to 2 seconds, while t final is equal to 2.1 seconds. So of course, we are going to apply the same definition. V average, it's given by x evaluated at t final, which is equal to 2.1 seconds, minus the position evaluated at initial time, which is 2 seconds, divided by t final, 2.1, minus t initial, which is 2. So we can write it as 10 times 2.1 squared minus 10 multiplied by 2 squared, divided by 0.1, which is the difference between 2.1 and 2. And we end up with the result 4.1 meter per second. So this is the first exercise. We end up with the results for V average in both cases. Let's go now to the second exercise. So a person walks first at a constant speed of 5 meters per second along a straight line from point A to point B, and then back along the same axis, but along the line from B to A at a constant speed of 3 meters per second. First question is, what is the average speed of this person over the entire trip? So the full trip. And what is her average velocity over the entire trip? So what is the average speed and the average velocity? Let's start with part A. So in part A, they are asking for the average speed. Going back to the lecture, you remember we defined the average speed as the ratio between the total distance traveled by the particle divided by the total time interval that is needed for the particle to travel the total distance. Since here the person, it goes first from point A to point B at a speed v1, which is 5 meters per second, let's call this path number 1, and v1 it's 5 meters per second. And then in the second path, which we are going to label it 2, it goes back at a speed that is equal to 3 meters per second going from B to A. So let's define what are the d total and delta t total. Okay, let's say d total, it is equal to the distance that the particle travels when it goes from A to B. So let's call it d1, saying that this is the distance in the trip, in the first half of the trip, plus the distance d2 that the particle travels when it goes back from B to A. But note that these two distances, they are equal. These two distances, it's let's say it's equal to d simply. And d1 plus d2, it ends up in 2d basically, where actually d is basically the length of this AB segment. So it's the distance that the particle travels between A and B. So the d total now is clear. Now, what is delta t total? In the same way, we can decompose delta t total between the first and the second path. So it's equal to delta t1 plus delta t2 between the first and the second path. And that's it. Now, what is delta t1 and what is delta t2? Those are the factors that we need to determine at the moment. What do we know about, let's take the path number 1. And the path number 1, what we know about this path is that the particle travels along this path with a constant speed of 5 meters per second. So we can say then that v1 is the speed. It is defined by the distance traveled in this trip divided by the time interval needed to travel the trip. So from here we can deduce that delta t1, it is equal to the distance d1 divided by v1. And we have already mentioned that this distance d1 is just d. It's the length of the AB segment. So d divided by v1. Let's continue. Along the path, the second part of the path, which is, we called it path number 2, we also know that the speed v2, it's equal to d2 divided by delta t2. And so from here we can deduce in the same way that delta t2, it is given by distance d2 divided by v2. And again, the distance d2 is the same, the distance d, so we can write it as d divided by v2. Now, what we need is to determine the average speed. So we still have to determine what is delta t total, but now it's very easy. You just have to sum up delta t total. It is delta t1 plus delta t2. So it's equal to d over v1 plus d over v2. We take a common denominator, so v1 multiplied by v2. We end up in denominator with v1 plus v2. Okay, that's great. Now we can simply deduce the average speed as d total divided by delta t total. So we end up with 2d divided by d times v1 plus v2. Okay, divided by v1 multiplied by v2. But actually, in the denominator, it becomes a numerator. So in other words, this v1 and v2, which is in the denominator of this factor, it goes up. And so we end up with 2d multiplied by v1 multiplied by v2 divided by d in factor v1 plus v2. And so here we can cancel out those two factors. And so we end up with this expression. So now we can simply write down S for average speed. It's equal to 2 multiplied by v1, it's 5, multiplied by v2, it's 3, divided by 5 plus 3. So that is equal to 30 over 8, which gives the value of 3.75 meter per second. So this is the average speed that we were asked about. Now, what is the other question? The other question was, what is the average speed of this person over the entire average velocity of this person over the entire trip? Okay, what is the average velocity in this case? Let's just get back to this picture, but let's draw it in here. So the person, as we know, it goes from point A, it travels from A to B, and then it comes back from B to A. So practically what happens is that it goes from X initial, that is the position of A, and then it comes back to X final, which is also the position of A, right? And so in this case, we know that the delta X is equal to simply 0. And we know from the definition of the average velocity that is proportional to this displacement delta X. So that means that the average velocity of this the person when it goes through the trip from A to B and then back to A, it has an average velocity which is simply 0. That's it for this question. Now let's move to another problem. Problem number 15. A particle moves along the x-axis according to the equation given by x equals 2 plus 3t minus t squared. So this is the equation of x as a function of time, where x is in meters and t is in seconds. At the time t equals 3 seconds, we have to find first the position of the particle, then the velocity and the acceleration of the particle. Okay, so let's start with part A. With part A, we need to determine x at the time t equals 3 seconds. Okay, that's clear. So we have x, it has the equation 2 plus 3 multiplied by the time t, which is 3, minus t squared, so minus 3 squared. And from here we result with 2 plus 1, 9, minus 9, which gives at the end 2 meters. Now, part B. We have determined the velocity of the particle at the time t equals 3 seconds. Okay, we don't have the velocity in the given, but we know what is the instantaneous velocity. By definition, the instantaneous velocity, it is given by v as a function, the instantaneous as a function of time. That means it's the derivative of x with respect to time. So that is given by the derivative of t of the expression 2 plus 3t minus t squared. And if you just make the derivative of this equation, you would end up with 3 minus 2 times t. So this is the equation of the velocity as a function of time. Now all we have to do is to evaluate v at the time t equals 3 seconds. So it's equal to 3 minus 2 times 3. And so it's equal to minus 3 meter per second. So that means that at the time we are looking at, the particle is moving backward with respect to the positive x direction because it has a negative sign. Finally, in part C, we need to determine the acceleration of the particle. Again, we know that the acceleration is given by definition by the derivative of the velocity with respect to time. So we are going to determine it. It is the derivative with respect to time of, this is the v as a function of time, so of 3 minus 2t. And here we conclude it is given by -2 meter per second squared. So as you may have noticed that the acceleration is constant. So acceleration is a constant. That means that the particle is under constant acceleration. Constant acceleration. And actually this could be seen from the beginning, because if you just have a look at this x, the x as a function of t equation, it's just very similar to the form x0 plus v0 t minus or plus half a t squared, with x0 equals 2, v0 equals t, and then half a it's equal to 1. So we could guess from the beginning that this equation of x as a function of t is an equation for the particle that is moving under a constant acceleration. So that's it. We are done for this exercise. Now let's move to the next one. Let's read the given. A student throws a set of keys vertically upward to her sorority sister, who is in a window 4 meters above. The keys are caught 1.5 seconds later by the sister's outstretched hand. Part A, with what initial velocity were the keys thrown? And part B, what was the velocity of the keys just before they were caught? So these are the two questions. Now let's discuss the problem. So we have a student, the first student, that is located somewhere, and then it throws up the set of keys to a sorority sister. So it's like بجمعية, you can think of it, who is in a window 4 meters above. So عمليا وكأنه عم بتزت لها على طابق ثاني، والصبية الثانية اللي هي السيستر تلقطها على من بعد ما كانت كبتها الستودنت ب 1.5 seconds. So the first question, let's start with the first question. What initial velocity? What was the initial velocity of the keys when they were thrown upward? Okay. So first of all, let's define a coordinate system in order to be able to draw all the objects in time and etc. So first of all, what is the object? The object that we are looking at, they are the keys. It's the set of keys. So this is the object that is moving, number one. Number two, how this object is moving, it's moving in a vertical direction. So the best coordinate system that we can take is this one, where you have the y-axis pointing upward, okay? And let's discuss what happened with the keys. So if we assume that the student is actually at the origin, so it's at sitting at the level y is equal to 0, and the sister is at the level y equals to 4 meters. So in this case, we can say that the keys, they are thrown up from this point, okay, with a given velocity v0, that is, of course, pointing upward, as they say in the given. It has an initial position y0 equals 0, and it has initial velocity v0. And then, so let's write them down. At time t0, we have y0, which is equal to 0 meter, and we have a velocity, initial velocity v0. Now, we know that they were caught 1.5 seconds later by the sister, which is sitting in a window or just stretching out hand from a window that is 4 meters above. So we can say at time t final, which is equal to 1.5 seconds, okay, y of the keys, which is y final, it's equal to 4 meters, very simple way. Okay, we don't know about anything else about this position when the keys were caught, but we know that y final is equal to 4 meters, for t final equals 1.5 seconds. So now we need to determine v0. Okay, to determine v0, we need to ask ourselves one question. What do we know? What are the variables that we know? So we can list them here, actually. We know y0, we know y final, we know t final, and we know also g. We know the acceleration that is actually acting on this object. So this object, whenever it goes up and then it goes down, it is under the gravity acceleration g. And so actually, we have to look for the equation that relates all these variables together, y0, y final, t, and the acceleration. So since we are in the case of a particle under constant acceleration, given that g is acting on it, then let's just take this. So the motions type is a particle under constant acceleration. Okay. And so we can apply all the kinematic equations that are correct and for the case of a particle under constant acceleration. And by that, I mean, for example, y as a function of t, v as a function of t, and all these equations. So in our case in here, what is the best equation that we can apply? Actually, the equation that relates y to t, it's simply y as a function of t, which can be written as y0 plus v0 multiplied by t plus half at squared. And since we are in the case for which a is equal to minus g, then this becomes y equals y0 plus v0t minus half gt squared. Now, if we evaluate this at the time t final, then this becomes y final is equal to y0 plus v0t final minus half gt final squared. Okay, let's just replace each term by its value. So we end up with 4 equals 0 plus v0 multiplied by 1.5 seconds minus half multiplied by 9.8 multiplied by 1.5 squared. And so if we just solve this equation, you would end up with v0 equals 10 meters per second. And this is the result that we are looking for. So that was the first part of the question. Let's now move on and just check again what was the second question. So the second question was, what was the velocity of the keys just before they were caught? Okay, so we are looking for the velocity when the keys were actually caught by the sister. So the keys were thrown up at this point. And then at this point in here, they were caught by the hand of the sister, right? So practically, we are looking first of all for v at a given instant t, right? But what is this instant t? If you think a bit about it, t هو الوقت يلي المفاتيح انلقطوا فيهم عمليا. So عمليا هيدي التي هي نفسها t final which is equal to 1.5 seconds. هذه هي التي اللي عم ندور عليها لانه بالوقت 1.5 seconds كانت already الايد لقطت الكيز وبالتالي اخر velocity كانوا عم يمشوا فيها هي باللحظه اللي لقطتهم فيها. What do we know about the velocity? We know that the velocity v is equal to v0 minus gt in the case of a particle in free fall, which is the case of our object. So the velocity v at time t equals 1.5 seconds is equal to 10 minus 9.8 multiplied by 1.5, and that gives the value of minus 4.68 meter per second. So it gives the value of minus 4.68 meter per second. Note that you have a minus sign in this value, and don't forget that the minus sign in the velocity v, which is evaluated at 1.5 seconds, indicates, what does it indicate? It indicates actually that at the time these keys were caught, the velocity was pointing downward, that v is directed downward at t final equals 1.5 seconds. At this time, the velocity actually was pointing in opposite direction with respect to the positive y-axis, which means that the keys وصلوا على محل رجعوا نزلوا
وهن منزلين لقطتهم السيستم. Okay, that's all for this problem as well. So let's move on to the next problem. This is a problem 51. Let us read the given. So, the height of a helicopter above the ground is given by h equals 3t cubed, where h is in meters and t is in seconds. So you have some helicopter that is, so let's say this is the helicopter, okay, that is somewhere above the ground, of course. So let's say that this is the y equals 0 reference, and let's take the y-axis to be pointing upward. So when we say that h is equal to 3t cubed is the height of the helicopter, that means that y of the helicopter, it is given by this ht function, which is 3t to the power 3. Now they say, after 2 seconds, so we believe that that means after 2 seconds from its departure, the helicopter releases a small mail bag. How long after its release does the mail bag reach the ground? So the helicopter at time t equals 2 seconds كبت ميل باك، وهالميل باك حكما بما انه صار بالهواء so عمليا صار free falling object under the action of the gravity acceleration. Okay, so هون لما كبت الفري فول، لما كبت هيدا الميل باك، اوكي اللي هو هالبوكس، عمليا هالميل باك حيوقع under the gravity acceleration. The question is قد ايه بده ياخذ وقت this mail bag to reach the ground? So how much time does it need this mail bag to pass from this height اللي هو حنسميه y0 لحد ما يوصل على هيدا الهايت اللي هو حنسميه y final, okay, which is equal to 0 لأنه عمليا it reaches the ground يعني عم يوصل على الهايت y final equals to 0. So how much time is it needed? What we are looking for is the time needed to reach the ground, and let's call it, I will call it TF. Okay, so we are looking for the value of this TF. So now let's just recapitulate a little bit. So what do we know about this mail bag, and what do we miss? What we don't know about this mail bag? So at this point in here, we know that it was thrown at a given point y0 with respect to the origin, and we know that it had some velocity when it was released from the helicopter, for the simple reason that the helicopter itself it is moving, so the object was moving with it, and at the time it was released, this object had the same velocity as that of the helicopter, right? So the mail bag, it has y0 and it has v0. How much are these y0 and v0? Well, since the mail bag was in the helicopter at the time it was released, so we can say that y0, it's simply given by y of the helicopter at the time the helicopter released the mail bag, so at the time t equals 2 seconds. And yh is nothing else than 3 to the times t to the power 3, so it's 3 multiplied by 2 to the power 3, so it's 3 times 8, which gives 24 meters. In the same way, v0, so v0, the initial velocity of the object, is the velocity of the helicopter when the helicopter it throws the mail bag, which is at the time t equals 2 seconds, right? But actually, we don't know what is velocity of the helicopter. All what we know is that the helicopter, it has this this function of t for the position. And since we know what is the definition of the instantaneous velocity, we can simply write down that v of the helicopter, of course, it's equal to the y helicopter divided by dt. And so it's the derivative with respect to time of 3 multiplied by t to the power 3, which simply gives 9t squared. Okay, that sounds great. So we can now evaluate v0. Then v0, it's given by vh at the time t equals 2 seconds. So which is equal by 9 multiplied by 4, which is 36 meters per second, right? So now what do we know? We know y0, we know v0, we know y final, and we know the acceleration. And what we need still, what is missing is tf. So this is tf problem. And this is the g, the acceleration. So the relation that relates actually the position to the time, it's given by y, t. In this case, for an object under a constant acceleration, which is the gravity, so in free fall, y is given by y0 plus v0t minus half gt squared. And so if we just evaluate this equation at time t final, we end up with y final is equal to y0 plus v0t f minus half gtf squared. So we end up with 0 equals 24 plus 36 t final minus 4.9. So 9.8 divided by 2, 4.9 t final squared. And so we end up with a second order equation in time tf. Now the solution of this equation is given by the positive value of tf, which is tf equals 7.96 seconds. So this is the time that requests or that takes actually the male back to reach the ground when it is thrown or released from the helicopter. 2 seconds at the time t equals 2 seconds, given that the helicopter, it moves with respect to the ground with this height given by 3 t3. Note also that the time, of course, is positive. So the time, as we have explained in the class, the time is a scalar quantity. So it's a number. If it's negative, it means that it's unphysical. So that's all about this problem. Let's move to another problem. Yeah, problem number 52. So problem number 52, it's on page 54 actually. A freely falling object requires 1.5 seconds to travel the last 30 meters before it hits the ground. From what height above the ground did it fall? So all what we know in this given is the following. The object, let's call this point B, okay? When it is at this point B, which is 30 meters above the ground, it needs 1.5 seconds to reach the point O. And from the question, we could guess that there is another point which is on top of point B, which is, let's call it point A. So the object was released in this point A. Then it reaches point B. Point B is at 30 meters above the ground. And from point B to point O, it takes the object 1.5 seconds to arrive. So what we need to determine is what height above the ground did it fall. So we need to determine the value of YA. So YA هو الunknown اللي نحن عم ندور عليه. Okay. Let's define actually the situations of each of these points. So at point A, what do we know and what do we not know? At point A, we know that VA is equal to 0, but we don't know what is YA. YA is the unknown we are looking for. At point B, we know that VB, there should be some VB that is not known. It's not our unknown, the VB, but still, I think we will need it in order to solve the problem, but we will see this later on. And we know that YB, it is equal to 30 meters, so it is known. And we have the point O, at which we have Y. So it's some velocity, of course, VO, and YO, which is equal to 0 as well. So what we need is determine who is YA, right? So if you just have a look at these 2 points, okay? These 2 points, they have both the velocities and the positions. And actually, in both, and so in each point, we have one variable that's known and the other is unknown. So that reminds us that there should be a relation that relates the velocity to the position. You still remember this equation? It's given by v squared minus v0 squared. It's equal to 2a y minus y0, right? And we are in the case of an object that is under the gravity acceleration. This object is all the time subject to the gravity acceleration g. So we can say that the initial velocity is a, the final velocity is b. So we can write this down. vb squared minus va squared is equal to minus 2g yb minus ya, right? va is equal to 0. Ya is the variable we are looking for, we don't know it. So we still need to evaluate or to determine the value of the velocity vb. How can we determine this input? Actually, we know what happens between point O and point B. We know that at some point the object was at point B, which is 30 meters above the ground. It had some velocity vb, which we are looking for, and then it takes this object 1.5 seconds to reach the ground, so it reaches y equals 0 practically. So let's just write down what do we know. We know that from B to A, from B to O, pardon, from B to point O, we know that y final is equal to 0, y initial اللي هي ال yb is equal to 30 meters. Okay, we know t final اللي هي if we can call it t ground basically, it is equal to t final as well, we can call it, is equal to 1.5 seconds. لأنه at this time t final the object reaches the level of y final equals 0. And so actually we need an equation that relates y to the time. So we know that the equation that relates y to the time is given by y as a function of t is equal to y0 plus v0 t minus half g t squared. Okay. Let's replace every term by its value at the time t final. So at the time t final, we can write down y final equals y0 plus v0 t final minus half g t final squared. Y final is equal to 0 because the object reaches the ground at this point O. That is equal to 30 in this case because the object at the initial time was at point B, who was 30 meters above, plus the velocity at time t initial in this case هي velocity لما كان على البوينت B قد ايه متى multiplied by 1.5 seconds minus 4.1 multiplied by 1.5 seconds squared, right? And so if you just solve the equation that we have written in here, you end up with the value of the velocity vb that is equal to minus 12.6 meters per second. So actually, this is vb. Don't forget that we have determined vb in order to use it in this equation in here, right? We have determined vb to use it in this equation so that we could determine ya. Let's do this. Let's do it so. So what we would end up with. So we end up with vb squared. It's equal to minus 2g yb minus ya, right? So minus 12.6 squared is equal to minus 2 times 9.8 multiplied by 30 minus ya. And solving this equation, we end up with ya equals 38.1 meters. So this is the value of the height, the initial actually position where the object was released. and it took him some amount of time to reach the ground. So of course, there are some other ways to solve this problem, but the point is that you have kind of two sections or two parts of this motion. The first part is between A and B, and we know few information about this part, but we don't know everything. And to complement our knowledge about this part between A and B, we go to the next part between B and O, and profit from this, the information in the given, that it took the object 1.5 seconds to travel the last 13 meters. And so at the end, we could be able to determine what is the position of the height from which the object was released. So that's it. We're done with the problem number 52. Now we go to the problem number 56. So this problem is very nice in some sense, because actually it provides an example of a time-dependent acceleration. So let's read it first. The acceleration of a marble in a certain fluid is proportional to the speed of the marble squared, and it's given in international system units by A equals minus 3v squared for positive v. Which means that, what does it mean? A is equal to minus 3v squared for positive v means that if the object is moving in this fluid with a given velocity, this fluid will be opposing the motion of the object. And of course, the acceleration is negative in this case, because the fluid wants this object to stop, and it will not help, and it will not push the object to accelerate, but it will oppose the motion of the object. If the marble enters this fluid with a speed of 1.5 meters per second, how long will it take before the marble's speed is reduced to half of its initial value? So let's just draw it in somehow. Let's assume that this is the front here where you have the fluid. So here is the fluid, right? Here is the fluid. So the marble, it enters the fluid, let's say at this point, with an initial velocity that is given by v0, which is of course in the positive direction. So if we take this to be the positive direction, which is x. Okay. So let's say at time t0, we know that the object, it has initial speed v0, which is 1.5 meters per second. Okay, meter per second. And we know that at some time t final, the object reaches a final speed, which is half of its initial value. That means that v final, it is equal to v0 divided by 2. And so it's 1.5 divided by 2 meters per second. Now, how can we determine this, this time? So to determine the time, we need an equation that relates the acceleration to the velocity and to the time, because this is all what we know. We know the initial velocity, we know this equation, and we need an equation that relates this equation or this information given by A equals minus 3v squared with the time. So what is this equation? Simply given by the definition of the acceleration. The acceleration by definition is the first derivative of the velocity with respect to time. So we can write down minus 3v squared times dt is equal to dv. As I told you in the course, whenever you have a variable and you have its differential, you always have to put them together. So that yields, actually, we can say it's minus 3 times dt. It is equal to dv divided by v squared. And so from now on, we can go on with the integration. So we make integral of minus 3 dt is integral of dv divided by v squared between some initial time and a final time. Okay, but before to go, so let's say from initial time t0 up to final time t. And of course, these limits have to be the same on both sides. So what is the integration of t? So integration of dt. The integration of dt is equal to t. So we end up with minus 3 t evaluated between t0 and t is equal to the integral of dv over v squared is equal to minus 1 over v. Okay, so just let's write it in here. dv over v squared integral is equal to minus 1 over v. That is up here. I'll write it down again here. Okay, so we end up with, so let's just write it down. dv over v squared integral is equal to minus 1 over v. And so we end up with minus 1 over v evaluated between t0 and t. So we end up with minus 3 t is equal to minus 1 over v minus 1 over v 0. Okay, so it's even by 1 over v 0 plus, it's in one plus minus 1 over v. Okay, so if you are looking at the time t final, we can simply write down 1 over 0, or let's start with the right hand side. So minus 3 t final is equal to 1 over v 0 minus 1 over v final. But don't forget that v final is equal to v0 divided by 2. So it's here 1 over 0 v0 minus 1 over v0 divided by 2, right? And so this yields 1 over v0 minus 2 over v0. So it's equal to minus 1 over v0. Okay, so we end up with then minus 3t final is equal to minus 1 over v0. So 3t final multiplied by v0 is equal to 1. And so we are looking for t final equals 1 over 3 v0. And if we replace v0 by its value, which is 1.5 meter per second, we end up with the value 0.22 seconds for the time. So actually, if this object, it enters the fluid that opposes its motion in such a way that the acceleration of the object is proportional to v squared with minus 3, the coefficient of proportionality, it takes the marble 0.22 seconds to reduce its speed by half, which is quite a lot if you just enter a medium, and this medium, it only needs fraction of minutes, so just 20 seconds to reduce your speed. That means that this fluid is quite efficient. Okay, I will put the example aside in a different video, because it's just a supplementary exercise. So that's it for today. Please, I would encourage you to solve yourself these problems, and I'll provide you with another version of the solutions, of course, with this version as well. And also, I would encourage you to do this this example. So I will just keep it in here. Just please, I will read it maybe, and then I will ask you to do it. So a stone thrown from the top of a building is given an initial velocity of 20 meters per second straight upward. So at this point in here, the stone was thrown up, okay, and it goes through this trajectory. So it goes from point A, it goes up, then it passes by a point B, and then it goes down, passing through C, D, and E. So the initial velocity of this stone is 20 meters per second. The building is 50 meters high, and the stone just misses the edge of the roof on its way down, as shown in the figure, in the adjacent figure. So actually, what happens is that the ball, it goes up, and then it reaches the highest point, and then when going down, it just passes next to the roof of the building, but it doesn't enters in collision with it. So it just goes very straight downward. Using the initial time that they call it TA to be equals to 0, as the time stone leaves the thrower's hand at position A, you have to determine different variables. So first of all, the time at which the stone reaches its maximum height. So what is the time t when the ball reaches point B? The maximum height itself. So how much is YB minus YA? So how much is the height of B with respect to the point where it was thrown up? So with respect to A. What is the time at which the stone returns to the height from which it was thrown? So what is the time needed for the stone to pass by point C? Because point C actually it is at the same level as the point at which the stone was thrown up. And finally, you have to determine as well the velocity of the stone at this instance. So you have also to determine the velocity of the stone when it passes through the point C. So I will give you this as an exercise and as the supplementary exercise for next time. Solve it, and I will provide you with the solution. Thank you, and bye-bye.